Welcome to this tutorial on Polynode's networks functionality. So in this tutorial we're going to have a look at the networks module and how it works in Polynode. So what I'm going to do is I'm going to start by uploading a new network. So I'm just going to hit new network here, and you'll see that the first input that is available to us is the network name. So this is a name for our network, and you can always find more information on each of these inputs by just hovering over this information icon. So this tells us this is a name to differentiate this network from your other networks. So I'm going to call this networks tutorial example. And we then have three options in terms of the file that we can upload. So we can either upload a network from Excel, graph exchange format, or JSON. So Excel is the most common format that that people use, and I will show you an example with that. But just to talk a little bit about these other two formats, graph exchange format is an XML type format that you can use to interchange network data with other tools. So whether it is a network X in Python or an iGraph in R, or another package that might be focused on network analysis and visualization, you can always click graph exchange format and upload a GEXF file directly into Polynode, like so. And then JSON is JavaScript object notation. So this is a format, the same format that Polynode's API takes. So it's a way of uploading that directly into Polynode. You can read more about our API in this network JSON format at docs.polynode.com if you're interested in that. But I'm just going to select Excel. I'm going to be uploading a network file that already exists. If you like, you can always download a template file. So if I hit download template, this is going to download a template file to my hard drive, which I can then view. So if I go here and click on this finder, here's the network template, and so I can just open this up, and this just tells me the format of the data. So we've got nodes, we've got edges, there's just two tabs. It's quite an intuitive data format, and for nodes, these are the entities in my network. And there's just one compulsory column, which is the name column. So here I've got this name column with Joe, Mary, Bill, and Grant. And there's a comment here that gives us a little bit of information about that name column. So these are the names of the nodes in my network. And then you can have as many optional additional attributes on the nodes in your network as you like. So here in this template file, we've just got example categorical attribute name just to illustrate how we can have some text data associated or attached to each of the nodes in these network. So value 1 and value 2 here. And we also have an example numerical attribute with some numerical data attached to each of these nodes in this network. If we hover over this comment, we'll see that there's a little bit more information on the attributes that you can attach. It just mentions that name is reserved, it's that unique identifier, and there is this option to include an image URL. So this is a URL in case you want to associate some images with the nodes in your network. You can do so by including a column called image URL and including a URL to the images that you want to appear on each of your nodes. And there's a few more notes here about the attributes for your nodes. And then if we go to edges, we just have these two compulsory columns, source and target. So this means there is an edge or relationship from Joe to Mary. So we assume that this is a directed network, but we do have the option of undirected networks as well. And from Grant to Mary, and from Bill to Joe. And we also have a comment here just explaining a little bit about the source and target. And we also have some example categorical attributes and an example numerical attribute for these edges as well. So this is data that we can attach to each of these edges. So that's what the template file looks like, in case you want to start with that. But what I'm going to do is I'm actually going to upload a little bit of a more interesting file for us to have a look at. It's actually a file based on the Enron email communication network. So I'm just going to hit this, and I'm going to go to my documents and my template networks and upload this example passive data network. And I'll hit open here. And we'll also just have a quick look at this file. So I'll open this up. It's the same format that I just walked through, so nodes and edges. Here we've got name. Remember, the only compulsory column for nodes is this name or unique identifier. And here we have a number of attributes attached to each node in this network. So in this particular file, we've got average daily emails, tenure, direct revenue, attrition probability, division, performance rating, salary, and gender. And we also have some labels on our nodes. So remember, there's nothing special about these attribute names. We can attach whatever data we like. This is just to illustrate. We've attached some data here. And the actual relationship data here is based, like I said, on the Enron email communication data set, but we've simulated some attributes for the nodes, and we've also changed all of the names in this network as well. And here we just have two compulsory columns, source and target. So this means there is an edge or relationship from Francis Swanson to Antonio Simon. And then remember, we can have as many attributes on the edges as we like. So because this is email communication data, we've got 2's and CC's. So this means that Francis Swanson emailed Antonio Simon directly 82 times over the period and copied her 31 times. But we could have other data attached to these edges. It's a very flexible and general format that we can use to upload literally any type of connected or network data. So that's what this data that we're going to be uploading looks like. And I'll just go back to the managed networks. And in Polinode, networks can either be public or private. So if your network is public, it's available to other people under this Discover module. If you have the ability to upload public networks, so all organizational accounts by default don't have the ability to upload public networks, but they can view other public networks. But we also support private networks, of course. And so a private network is a network that only you have access to, or the people that you grant access to this network. So that's what we mean by a private network. Much like if you have come across GitHub before, how there are public repositories and private repositories in GitHub. So I'm going to make this a private network. So it'll just be visible to me for the moment. And then we have the option of this network being directed or undirected. So a directed network just means that the order of the edges has meaning. So because this is email data, it makes sense for it to be a directed network. So person A is emailing person B. An undirected network might be, for example, a Facebook friendship network. So that's an example of undirected, because if I'm your Facebook friend, then you're necessarily also my Facebook friend. But this is a directed network, so I will leave this as a directed network. There's some optional inputs here. So if I click this, you have the option of adding a description to your network. So you can write some descriptive or explanatory text. If you do this, that description will be available to you on the right-hand side of your network whenever it's opened in the Explore view by you or by other people. You can put images in there, you can use headings, bold. Yes, it's the ability to add a description to your networks. I won't do that in this example. And you can also upload an image if you like, an image associated with your network. If you do this in the card view for Polinode, you will see an image associated with that network. So where we see right now this EN comes from the example network name, but if we were to upload an image, we would see that image on the card representing that network. So I'm going to leave both of those blank as I upload this, And I'm just going to hit create. Takes a couple of seconds, and now that network has been uploaded, and you can see we have this card for us. As soon as we hover over that card representing this network, you'll see the open network text appears, and we can just click anywhere in this box, and it'll open the Explore view for that network. So that's what we're going to do immediately now, is just hit Open Network. And now that data which you saw in the Excel file is now available to us in this Network Explore view. And immediately what Polinode does is it runs a force-directed network layout algorithm. And that layout algorithm essentially simulates physical forces, right? Such that the nodes in the network that are relatively closely connected to each other are positioned relatively close to each other in space. So intuitively, this group of people here are more connected to each other than they are to the rest of the network. We can also see we have a group up the top right here as well that are kind of more connected to each other than they are to the rest of the network. If we hover over a node, so let's hover over Danielle, we can see all the attributes associated with Danielle. So everything that we saw in that Excel file previously, we have available to us in this Explore view on the right-hand side there. So we have attrition probability, average daily emails, direct revenue, division, gender, performance rating, salary, and tenure. If I click on Danielle, it will select Danielle. We can see then Danielle in this right-hand side window, and we can also see her ego or her personal network. So who is she directly connected to? And if we click on edges, we can see all those incoming edges and any outgoing edges she may have. So Danielle doesn't have any outgoing edges here. We can click this cross to clear that selection, or we can just right-click anywhere that's not over a node in order to clear that selection. You can also search for any nodes by name. So I just start typing Eugene, and immediately we can click and select Eugene just by search and select. And then I'll just unselect Eugene. You can zoom in using the scroll button, scroll wheel on your mouse, and zoom out like so. You can also move nodes around very easily if you want to reposition them. So kind of all that, call it core functionality around interactive network analysis and visualization. There's a few keyboard shortcuts. One of them is the S key. So if we're just kind of in this Explore view and we hit the S key, it will just zoom us out or zoom us into to this, to fit the screen with the network. Now, where things get really interesting and powerful with Polinode are all the things you can do on the left-hand side here. So I'm just going to go through and show you all the different things in this left-hand side menu. The first place I'm going to go is metrics. So these are the metrics that we can calculate on our network. Immediately you see we've got nodes, edges, and network. So we've got kind of 3 tabs for the metrics that we can calculate. And then what you see here are the 5 basic metrics that are available to you in Polinode. So we have community detection. So this is the Louvain community detection algorithm. And this is an algorithm that will partition the network into groups of nodes that are more closely connected to each other than they are to the rest of the network. So there's a greater density of connection within the communities that this algorithm finds. We then have external versus internal. So this metric, you give it an attribute, like for example, gender here, and it will look at the connections of each node, and it will determine what proportion of their connections are to people that share the same value of that attribute versus a different value of that attribute. And then the last 3 in these basic metrics are in degree, out degree, and total degree, which are slightly complicated names for very simple concepts. So in degree just means the total number of incoming connections that each node in the network has. Out degree just means the total number of outgoing connections that each node in the network has. And total degree just means the total number of connections that each node in the network has. And so in degree in particular is often referred to as the simplest measure of centrality in the network. So those nodes that have more incoming connections are often said to be more central in the network. You have the option here of applying edge weights. So if you want to calculate a weighted integrity and you have some weights on your edges, that is some numerical attributes on your edges, you can do so. Now, in order to do that, you first need to size your edges by the numerical attribute that you want to be used as the weight. So we haven't done that yet. So if I was to go to apply edge weights here, yeah, it gives me the option, but it's not going to use a particular attribute for those edge weights. So we can use that edge weight as either a sum or average, but for the moment I'm just going to calculate the integrity, but just without applying the edge weights. So I'll calculate integrity, and I'm also going to calculate communities. So my Louvain community detection algorithm as well, so we can have a look at that together. And you'll see that that's added 2 layers to the network. And layers in Polinode work a lot like layers in Photoshop, in the sense that we can stack multiple layers together, and the order has a meaning and they're applied in that order. So that's very important because we can apply filters before some operations and everything gets applied to just the visible network. So if we were to, for example, filter the network so we look at just the females in our network and then calculate integrity, the integrity that would be calculated is just for the females in the network, that is just for the visible network. These are the basic metrics in Polinode, like I mentioned. If you want access to the advanced metrics, just toggle this here and you'll see all of the advanced metrics. So here we have advanced community detection, we have betweenness centrality, closeness centrality, eigenvector centrality, page rank, and a whole range of other metrics. Now, I'm not going to go through all of these metrics individually. There's a description for each one here, and there's also links that will take you to web pages that have more details. And a lot of them have inputs. For example, here's page rank, and we can change the alpha of our page rank calculation, which is the attenuation factor for that page rank. We also have edge metrics. So we have edge betweenness, we have external, we have mutual edges, and we also have some helper metrics too. So for example, here we have the ability to rename an edge attribute. So this is actually a helper metric that allows us to rename edge attributes, and we have a similar helper metric for nodes and a couple of other helper metrics too. And under network, you'll see these are the overall network metrics. So we can calculate the average path length for the network, we can calculate the average total degree, and this actually gives us a real-time result here. We can calculate the density for the network, the diameter for the network, or the number of edges, or the number of nodes for the network. This is always dynamic to the visible network. I might just calculate an example here, just so you can see what a network metric looks like. So I'm just going to calculate and add this as a layer as well. One slightly different thing about the network metric is you'll see the actual number. So unlike the node and edge metrics, which add attributes to the nodes and edges when they're calculated, the network metric is just generally a single value, and so it's available here in the layer as that value. So here we can see that the number of nodes for this network is 364, the visible number of nodes. So if we now go back to Danielle, which was the node that we were looking at previously, and hover over Danielle, you'll see that Danielle has a value for communities of community 1 and a value for integrity of 3. So Polinode has added attributes for these node metrics that have been calculated. So they're added to the nodes. Now, if we calculate edge metrics, they would have been added as attributes to the edges. So again, we can click Danielle and we can see that value for communities and that value for integrity, and clear that selection as well. So that's a little bit about the metrics. We've also spoken a little bit about layers. You've seen how we can add some layers, and we'll see some other layers too. You can always get back to layers just by toggling this. So this will show or hide those layers. You can collapse all the layers like this, or you can hide the layers here. And this reset view button will just clear all of the layers and all of the visual settings in your view if you want to reset your view. So that's what that option does. So let me just hide these layers again. And now I'm just going to have a look at some other layers. So I'm going to have a look at coloring. So if I go to color, you will see that we can color nodes, edges, or labels. So this is the bottom drawer here. I like to remember this as like a 3x3 for color, size, and filter. We can always color, size, filter any of nodes, edges, or labels, and these are all available to be added as layers in our to our view as well. So if I go to color and now I go to communities, here are the 8 different communities that Polinode has detected. So remember, communities is an algorithm that will partition our network into groups of more closely connected nodes, so informal communities or groups. And I can add this as a layer. So this then gets added to my list of layers that I'll be able to preserve as a view as well. I could also color edges if I wanted. So the default here is that my edges are set to this custom color, but I can color edges by a source node, by a target node, by this custom color that I can change or configure if I want to. So I can change my custom color here, or I can color my edges by an attribute as well. So here I could color by CCs, which is an attribute I have available to my edges copies, or I could color by 2s, likewise if I wanted to as well. But I'll just leave my edges uncolored for the moment. We don't have labels visible other than when we hover at the moment, but you can also color the labels. You can change the custom color, or you can color labels of your nodes by an attribute as well. So that's what color does. You also notice that as we use these different menu items on the left, they become blue. So this just helps us visually understand what is active in our network at the moment. So layers is blue because we have at least one layer. Metrics is blue because we've calculated at least one metric. And color is blue because we've colored by at least one attribute. So we've got colored the nodes by communities. Now we'll go to size, and you can change the size like so, just with all nodes having the same size, just using this slider. But we can also size by numerical attributes that are available to us on the nodes. So this is a great example of being able to use in degree, which is that second metric that we calculated. So I can select in degree here, and I can use my slider, and now these larger nodes have a greater value for in degree. So I can adjust my min node size and our max node size, like so. We also can use these thresholds that will just allow us to control where that min and max node size kicks in. Now add sizing as a layer 2. And we can always edit these numbers that you see. When you hover over a number like this, you'll see a little edit icon. This tells us that we can edit this. So if we click in here, we can change this to, for example, 30 exactly. But I'll change this back to 32, the max value. And I'll add this as a layer. So I'm sizing the nodes by in degree now. We can also size edges. So we can size edges. We can change the size here of all the edges, or we can size our edges by an attribute like CCs. So now the larger edges here are those edges or relationships between two nodes that have a greater value for CCs. And I could size the labels as well. But I'll just size nodes to keep things simple. I can go to filter, and again I can filter nodes, edges, or labels. So now I'm just going to filter the nodes in my network by, let's have a look at filtering by the communities that we're coloring by. So here I can see I select communities, and here are all the attribute values for these communities. I click on this, and I can very easily, unselect, say for example, community 1, and now that will be removed from my network. Unselect community 2, or I can add them back in, or I can deselect everything or select everything. So it's very easy for me to filter out attributes. So here's an example of filtering out by some categorical attributes, but here's another example of filtering out by some numerical attributes. So I have direct revenue as an attribute, and I can filter my nodes out by that direct revenue. And so if I wanted to, I could add this as a layer. And remember that everything in Polinode is dynamic to the visible network. So if I apply these filters and then do something like calculate metrics afterwards, the metric that is calculated will be dynamic to the visible network. But I'll leave all of my nodes visible. And remember, you can also filter your edges if you like. And just like nodes, everything is dynamic to the visible edges too. And I can filter labels as well if I want to. Now, you probably noticed that after we sized the nodes in our network, we got a little bit of node overlap. So I just want to show you quickly how we can deal with the overlap. So if I go to layout here, I can actually run my force-directed layout algorithm, which is always the default that's visible and available to you, with prevent overlap on yes. So I'm just going to run this layout algorithm with prevent overlap on yes just for a few seconds, just to make my network look a little bit nicer. And we can also talk a little bit about what we see here with the layout. So you'll see that we have this force-directed layout algorithm, which is the most common or popular one to use. And you'll see that we have a duration that this layout algorithm is going to run for. So the default is 5 seconds. Sometimes you'll want to run this for longer, so you might want to change the duration because basically you want to run the force-directed layout algorithm until the nodes stop moving, until they kind of reach an equilibrium. We also have some inputs for the different parameters that you can set for the force-directed layout algorithm. So gravity, repulsive force, edge weight influence, and also this kind of speed or slowdown parameter as well. If I click on this, here are some other network layout options. So I have a lens option, which is helpful for me, particularly if I have some kind of disconnected components. If I want to keep them included in the network, I can run this lens layout algorithm. I also have distribute nodes. So distribute nodes is another great way of getting rid of overlap. It will distribute nodes, creating some space between overlapping nodes. The org chart and tree network is great if I have, for example, a formal reporting network, so a tree network. I can use Polinode in order to run the org chart or tree layout and create what looks like an org chart inside of Polinode. The plot nodes layout allows me to plot my nodes on an X and Y axis, so Cartesian coordinates, and that can be by any attribute. So I'll show you an example of that. But it allows me to, for example, plot these communities that I've calculated versus the integrity that I've calculated, but by literally any metrics or by any attributes that I bring to Polinode. The reposition isolates will move all of the disconnected components and isolates in my network down to the bottom. And then I also have these charts. So this allows me to create a collaboration matrix or a membership matrix in Polinode. So I'll also show you an example of that and come back to that soon as well. The reason why I just want to pause before showing you some of the other layout options is I first want to save a view. So these different operations that I've applied, I want to actually go here and I want to save a view, and I want to call this view A, and I will call this view sized by in degree and colored by communities. Now, when I save a view, what's going to happen is Polinode is going to preserve all of the visual settings of my network. So all of the colors that you see, as well as all the positions of the nodes, and it's also going to preserve all of the different layers that have been applied. So in Polinode, you can have up to 50 views per network. And each one of those views can have multiple different layers stacked on top of each other. And the layers and the views sit on top of the underlying network data. So you have your underlying network data, and then you can have 50 different views, and then each one of those views can have multiple different layers in them as well. And so when you open a network and apply a view, those different operations as well as the visual settings get applied to your underlying network data, just for that view. We have the option of setting this view to be the default view. If it's the default view, this means whenever I open this network in the Explore view, this view will be applied by default. So I'm just going to hit save on this view, and now we have this default view applied. And you'll see that up here we have the name of the network and then an arrow, and then it also tells us what view we're looking at in this network as well. So yeah, it saved all of my visual settings as well as the different layers. Now, if I go back to layout, I can show you some of these other network layouts that I mentioned. So here I can go to Lens, I can hit Reset, and now if I run this, we'll get this Lens layout. But suppose I want to go back to what I had previously, I can go to Open, and I can open my Save View, and now this Save View with all the node positions comes back. We also have distribute nodes. Let me show you plot nodes. So here we can plot the nodes, remember, by any of the attributes. So let's do, for example, communities on the horizontal attribute and in degree on the vertical attribute, like so. And now horizontally, we have these different communities. So here we have community 3 being the brown community and so on. And we can see in each of these kind of informal groups or communities who has the greatest number of incoming connections, which is that the simplest available measure of measuring influence in this network. And I'll also show you the collaboration matrix and the membership matrix too. But I think the easiest way of doing that is actually, if I open this view up, and now I actually will go back to color, and let me color the nodes here by division. So here we're looking at the division, and I'll just add this as a layer 2. So here you can see that this group up here is actually research and development, R&D. Here. Here you can see this group here is part of services, and you can see how intermingled services and customer support are, and what these where these different divisions sit relative to each other. And if we go back to layout now, if we look at this collaboration matrix, we can run this collaboration matrix with division as the row headings and division as the column headings. And I just hit start. And now we get a collaboration matrix. And so the way that we read this is that the row headings here are the froms and the column headings are the tos. So this means in terms of the nominations that come from accounting, 55.9% go to accounting, 2.4 to customer support, 1.8 to the executive office, 1.2 to HR, and so on. So each one of these rows adds up to 100%. And so we can see that R&D, which is that group that we saw up the top right, somewhat separate from the rest of the organization, R&D to R&D is 99.3, and then R&D has some connectivity into services. So these collaboration matrices can be very helpful in combination with the network visualization. And we can also use these sliders just to look at certain parts of that collaboration matrix as well. and we have this normalize by size option. So when we normalize by size, what happens is we will divide everything in the collaboration matrix by the relative size of the groups, so that we will obtain basically the ratio of each cell to the relative size. So we would expect, if people were connecting at random, each of the cells to be equal to the relative size. And so when we divide by the relative size, if a cell is greater than 1 times, then people are connecting more than what we would expect relative to random. If it's less than 1 times, it's less than what we would expect. And a membership matrix is helpful. So let's do a membership matrix of division versus communities and just hit start. And so now what this is telling us is that if we look at accounting, 70.6% of accounting is in Community 1, that informal grouping of Community 1, and 29.4% of accounting is in Community 2. And we can see that all of IT is in Community 3. So it helps us look at this formal grouping of division or team versus the informal community structure, very easily and very visually. But let's go back to that force-directed layout like so, and let's actually put some labels on my nodes. So just to keep things simple and clean, by default, Polinode only shows labels on click or hover. But if we go here and put some labels on our nodes, we can change this so that the show labels is always. And then what we do is we get a label for all of the nodes in the network. And of course, the whole screen fills up with labels like so. But what we can do is we can go to filter, and we can filter the labels by the same attribute that we're sizing by. So we're sizing by integrity. And now we get labels on just these largest or most influential nodes in the network. And we can add this as a layer as well. And we could, for example, actually update our view at this point. So if we go up to save and go to update open view, this gives us the option of updating the view. So suppose we want to change the view so that we're coloring by division, which we've changed, and also adding these labels. We can go to update open view, and we can hit update, and this is now going to update that view that we saved previously. If we had wanted to create a new view instead of updating that view, we would go to save, and we would do save new view, and we would type the name of our new view and then hit save. So that's how we can update a view using save. You've also seen how we can open a view using this open and manage views functionality, and this also lets us delete views or change what the default view is as well. And we should talk a little bit about templates. So the templates functionality here allows us to create our own template views. So a template view might, for example, have your own set of colors or your own visual settings, or it might have a set of operations or layers that you want to be able to apply just with a single click. And a template view is available to you across all of your networks and gives you the ability to apply that view just with a single click. So we haven't saved any template views, but if we were, they would be available to us here, and then we could apply it with a template. We could apply that template with a single click. So that's what template views are. We've also now seen labels and how we can change those labels. We also have the ability to change the label background color if we like, and we can change what attribute we're using for that label. So the default will be name, but suppose we want the labels to be gender instead, we can change it. But let's go back to name here, and we can change the labels from bold to regular text too, just a visual setting. We've seen filter, and now we'll go back to shapes. So shapes gives us the ability to dynamically set the shapes of our nodes by any node attributes available. So here I can go and let's select gender, and you'll see that now the females are circles and the males are triangles. and we can edit the shapes if we like. So suppose we want males, instead of being triangles, to be squares. We can change it. And now we can see that the males are squares and the females are still circles. So this is how we can set the shape of our nodes by any categorical node attribute that is available to us. And that can also be added as a layer if we wanted to. The other thing that you'll see here is roll-up. So the roll-up allows us to roll up the nodes in our network by any categorical attribute. So if I click on roll-up, I can roll these nodes up. Let's roll them up by division because that's what we're coloring by. And so this now creates a new network where each of these nodes represents the attribute values for these divisions. So we've got accounting, we've got services, customer support, and so on. So it creates that new network. And I can hit clear, and we get back to our unrolled up network. Now, if I go to export, I can have a look at the export options. So we can export any of our networks, any of our network views to PNG. So here, if I hit export, it will export this network to PNG. We can also export to Excel. And when we export to Excel, we have the option of either exporting the full network, which will be all of the data in the network, including the metrics that have been added as attribute values to either the nodes or edges, or we can export just the visible network only. And we can also export to graph exchange format. So this is helpful for importing this file into other packages that might take graph exchange format. Yeah, we can export to graph exchange format. One thing to note about Excel is when your layout here is set to force director or any of these network layouts, you're going to get the network with that same kind of nodes and edges format that you saw us being able to import networks in. But if we have the collaboration matrix rather than one of these network layouts or the membership matrix, and you go to export to Excel, it will actually export that membership matrix or that collaboration matrix in Excel format. And then the last option that we haven't seen yet is this settings option. And so here, if we click on settings, we see we have edges, legends, selection, and background. So here, this just gives us a few stylistic options for our edges. By default, we have curved edges, but we can change our edges to straight if we like. Let's go back to curved. We can also toggle our edge display off. So this is helpful for larger networks because it's faster to interact with this network, particularly if you have a large number of edges with show edges toggled off. And you might see for quite large networks will actually automatically turn the display of edges off and give you a notification that we've done that. If you have self loops, so that's nodes that are connected to themselves, you often want to remove those self loops, and we have a toggle here that makes it very easy to do that. We don't have any self loops in this network. And then we have arrows, so you can turn on or off the arrows if you like. Now, if this was an undirected network, you wouldn't see this arrows option because the arrows are off by default. But here we have the arrows back on, and we can change the size of the arrows as well. You can also toggle any of the nodes legend, the edges legend, the labels legend, or the shapes legend as well. Now here we're just coloring by a node attribute, so we just see the nodes legend. So here's an example of being able to toggle that on or off. While we're talking about the nodes legend, note that you can always click here and just very quickly change the color just through this legend if you want. So suppose we want a brighter yellow, we could do that, or we could enter individual RGB values like so. So that's one way of changing the colors. Another way is, and here we'll talk a little bit about editing layers, is we can always click this edit button like so, and then click edit colors, and we can enter or copy individual RGBA values in here to change the colors very easily for the nodes or the edges in that way as well. But back to settings. So here, as I mentioned, you can toggle the individual legends on. And then we also have some settings over the selection. So when you select a node, so let's select, say, Danielle Porter here, for example, the default is that it will select the node that you selected plus the neighbors of that node, and also will show all the edges. But we can change this so that we'll look at just the selected node and their in and out edges as well. So here it's removed the edge between these two neighbors, Janie and Valerie. Or alternatively, it can show you just the in edges. So all three of these are incoming edges, or just the out edges for that selected node. And here, this node doesn't have any out edges. So this is how you can kind of control that selection. And you can also change what's getting selected. So rather than the selection being the node plus neighbors, you can change this so just a single node will be selected when you use your mouse to select the nodes, like so. So that's how you can configure or change the way that selection works. And you can change the background color. So here we've got a dark background, but we can easily move to a light background if we want. And we can even change the alpha transparency of our background. So here we can change the alpha transparency to 0. And now if we were to export this PNG, we would get a transparent PNG. But let's go back to our more regular background like so. Just a few more words on the layers that you see here. So we've got a few layers now. I've shown you how you can edit these layers. So you can always just click this edit icon in order to edit any of these layers that you like. So let's say we want to change our in degree here. We can hit that edit button, and here we see this is our in degree metric here. So we can click on any of these layers in order to edit that operation. The other icon that you'll see to the right of that edit is delete. So you can edit and you can also delete individual layers. So see here we've got color nodes by communities, and then we've got color nodes by division. Well, we actually don't really need this color nodes by communities because we're subsequently coloring these nodes by division. So let me hit this delete button and I'll remove that layer like so. For most layer types, you also have the ability to toggle them on or off. So not the metrics, but here we can actually toggle the sizing the nodes by in degree. And so now we're no longer sizing by in degree, or we can toggle it back on. So that's what this little I button does, is it toggles that layer on or off. And I'll just hide these layers. And then of course we've got this collapse icon here that will just kind of collapse that left-hand side menu to just icons in case you want slightly larger or slightly smaller left-hand side menu. So that's most of the network's functionality. There's a couple more things just to be aware of, one of which is there are some keyboard shortcuts. One of the most helpful of those is actually the #1 key. So if I go back to selecting Danielle, and if I hit that #1 key, what that actually does is it selects the neighbors of all of the selected nodes, and I can repeatedly select that #1 key to expand my selection to the neighbors. So some of those kind of more advanced features like the keyboard keys you can actually read a little bit more about in our online docs at docs.polinode.com. But that's a fairly thorough overview of the interactive network analysis and visualization functionality in Polinode. I'll just hit the back button here and just say a few words about the functionality that's available in this, call it the list of networks or the card view of networks. If I click here, you'll see that we have available to us this edit option. If I hit edit, this allows me to edit or change the name of my network, but I can also update the underlying network data. So suppose I want to change some of my nodes or my edges or the attributes associated with my nodes or my edges. I could hit this edit button and I can update the underlying network data that I previously uploaded, and that will change the underlying network data. And remember that the views in the network sit on top of the underlying network data. So then all of those views that you might have saved will be applied to that updated network data sitting over the top of it. I could also make this a public network instead of a private network, or kind of change any of those network settings. I could also duplicate this network, in which case not only the underlying network data, but all of the views associated with this network will be duplicated as well. And I can manage the users for this network. So this particular network is one that only I have access to, but I could, for example, give access to another user by hitting this add user. And I know that we actually have another user in this organization under this email address here. So I'll just type her email address, hit check, and now it tells me which organization this user is in. If they are in multiple organizations, you'll actually see a drop down here. So you can select the organization that you want to give them access under. And we also have this permission level. So we can actually give this user, say, only view, so view only access to this network, or edit access. And we can control whether they have the ability to add other users to this network or not, and whether they have the ability to remove users that have access or not. So let's add this user with full permissions, like so. And now Jane Citizen has been added as a user that has access to this network. You can also upload users in bulk using this upload users button. And I can export this network data to Excel, like so. And then I'll have that available to me in Excel, the same format as I imported in. I could archive this network, and if I archive this network, it's no longer visible. So if you have a large number of networks, but you're only working with a few, it's often helpful to archive those that you don't want immediate access to, just to keep this view, relatively uncluttered. But now if I toggle here, it'll show me that archive network, and we see this label of archived and also this little circle that tells me that this is an archive network as well. And we can unarchive this network, and now that network is no longer archived. I can also search for my networks by name, like so. And I can change the way that these networks are being displayed. Instead of by the last modified date, by the name of the network, or back to the last modified date. And then I can delete networks as well. So I can delete individually like this with this delete option in this menu. Or alternatively, I can actually select multiple networks like this, and then I have operations that are available to me for multiple networks. So one of those operations is delete, so I could delete both of these networks if I wanted. Another operation is archive. And then we have this other operation that's called combine. So this gives me the ability to create a new network by combining multiple of my existing networks. So if I hit combine, I can give this new network a name, determine whether it's public or private, and create a combined network from two or more of my existing networks. But let me just delete this networks tutorial example that I just created, like so. And that concludes the end of this networks tutorial.